Okay, here we are with sequences 1.7. So we're looking at both, kind of comparing arithmetic and geometric sequences. Okay, so remember with arithmetic sequences, that common difference, okay, that's how much we're adding or subtracting, because arithmetic grows by repeated addition or subtraction. So if f of 1 equals 2, and my common difference is plus 3, so that'd be plus 3 each time, right? So I'd go 2, then 5, then 8, 11, 14. Okay? Whereas with my geometric, g of 1 equals 2. Okay? And remember that f of 1, same as a sub 1. Okay? Or g of 1, same as a sub 1. Alright? Now the common ratio, because geometric is through multiplication or division of 3, means I'm timesing by 3 each time. So 2 times 3 would be 6. 6 times 3 would be 18. Times 3 would be 54. And times 3 would be 166. Better double check that one. Nope, not 166, 162. Still better double check it though. Yep. Okay, so then the next question is, without figuring it out, okay, when I get to the 100th term, for the arithmetic or the geometric, which one is going to, do we think is going to have a higher value? Well, if I look at this, I should see that I'm only at 14 here. I'm already at 162 here, so my guess is g of 100. Why? Well, when we multiply, it grows faster, right, than addition. Alright, let's look at number 2. Okay, so arithmetic, f of 1 equals 2. This time we're adding by 10. So 2 plus 10 would be 12, and 22, 32, 42, and so on. Okay, for geometric, we start at 128. Common ratio is 1/2, so we're timesing by 1/2. So 128 times 1/2 would give us 64. Times 1/2 would be 32. Then 16. Then 8. Okay, again, which one is going to give us a greater value? Well, arithmetic here is adding 2, whereas we're getting smaller in geometric, right? So I'm pretty sure arithmetic, once we get to 100, is going to be a lot bigger. Why? Because that one is, increasing, going up, whereas the geometric is decreasing, isn't it? Okay, now number 3. Arithmetic sequence, f of 1 equals 20, and we're adding 10 again. So it would be 30, 40, 50, 60, and so on. For geometric, we're starting at 2, and we're timesing by 2. That's our constant ratio. So it would be 2, 4, 8, 16, 32. Okay? So if we just look at this one, you may think, oh, well, this is a bigger number than this one. Okay? But think about it. The bigger these numbers get, the quicker we're going to move. Okay? So based off of that idea, again, I'd go with geometric. I'd kind of do the same reason as that. But if you needed to double check, g of 6 would be 64 and then 128. Already, f of 6 and f of 7 would only be up to 80. So pretty quickly it will overtake it by doubling. Right? So let's keep looking at these. So start at 50, and we're subtracting 10, so 40, 30, 20, 10, and so on. Okay. Then the geometric, we start at 1, and we're timesing by 2. So 2, 4, 6, 8. Which is going to be bigger? Well, this one's getting increasing, whereas this one is decreasing, right? So definitely geometric, because it's increasing while the other one's decreasing, right? So g of 100 is increasing while f of 100 is decreasing. Alright, what about number 5? Okay, we start at 64 and we're subtracting 2 each time. So it would be 62, 60, 58, 56. Whereas the geometric one also starts at 64, but it's going down by half. 32, 16, 8, 4. Okay, now this one's going to be tough to understand, okay? Because you're probably looking at it would think, oh, it's going to be that one, okay? But it's actually not going to be by the time we get to f of 100, okay? And the reason being this, okay? This geometric, we're always cutting it in half. Well, I'd go down to 2, then 1, then 1/2. I'm never going to get to 0 here, okay? Because cutting something in half never completely gets it to leave. Whereas if I keep subtracting 2 here, eventually I'm going to get into negative numbers, and I'm going to be below 0. Okay? So it's going to be pretty close, though, being that, you know, we have 100 steps to go. So it could be pretty close, but I'm pretty sure that it's actually still going to be the geometric. For that reason, because it's never going to cross 0, whereas the arithmetic one will. Okay? Alright, so considering arithmetic and geometric sequences, would there ever be a time that a geometric sequence does not outgrow an arithmetic sequence in the long run as the number of terms of sequences become really large? Okay? So, it kind of depends, right? Because we can see if one's getting smaller, like generally the geometric works every time, except in this case where this one was increasing and that one was decreasing, right? So, but if the number of terms of the sequences are getting large, okay, so basically if geometric is decreasing and arithmetic is increasing, it's really the only time that geometric isn't going to be let's say other than that, geometric all the way. Eventually it will overcome the arithmetic. Okay? There we go.